Hi everyone, my name is Muhammed GOLEC. I'm a PhD student at Queen Mary University of London Computer Science. Today I am pleased to present our work called AIBLOCK blockchain-based lightweight framework for serverless computing using AI. The slide consists of six main sections. These are background, introduction, motivation, AI block, performance evaluation, conclusions, and feature work respectively. First of all, we will take a look at two key concepts to better understand the AI block framework. These are serverless computing and blockchain. Before explaining the concept of serverless computing, let's start with a question. What is cloud computing? Cloud computing is an internet-based computing service that provides computing resources that can be shared among users. Cloud computing has many advantages. Cost efficiency. Organizations don't have to pay license fees for each user. Large storage space provide ample storage and processing power for processing power-constrained devices where massive data is generated. Easy access to information. Easy access to information from anywhere with the internet. Before cloud computing, companies were investing heavily in hardware and infrastructure to build servers. Cloud computing has saved companies from maintenance costs such as hardware, operating system, network, and security with the hardware service rental models. However, customers still had to deal with infrastructure and platform issues such as operating system updates of the leased server, kernel patches, and predicting the processing power and storage space to be used. To solve these problems, serverless has emerged as a new paradigm. In serverless computing, the infrastructure and platforms on which the services run are hidden from customers. Serverless computing In serverless computing, there is less operational complexity. The service given to the customer isn't based on hardware and software, but on a function basis. And the service provider takes care of the server part. By applying the pay-as-you-go pricing model, customers are priced only for the processing power and storage space used. Due to the auto-scale feature of the serverless computing, the requested resources are scaled automatically if the customers need them. Now, let's take a quick look at another concept, blockchain. Blockchain is one of the most useful technologies that offers information security. Blockchain is one of the most useful technology to offer information security. Blockchain consists of blocks created by digitally signing each block and appending this block with its hash value to the previous block. Blockchain has a wide range of uses. For example, it has been utilized in financial systems with digital currencies such as Bitcoin and in areas where smart contracts such as Hyperledger are used. Each new block added to the blockchain is processed together with the hash of the previous block and added to the end of the chain. Any attempts at modifying any block will affect the hash value of each block in a chain. That is why blockchain provides immutable data storage. Blockchain is promising in IoT applications where data integrity is important. Now that we have introduced the general concepts, we can continue with the introduction. The coronavirus COVID-19 epidemic caused by severe acute respiratory syndrome is a pandemic that is in effect since December 2019. Worldwide, this pandemic has had devastating effects both socially and economically. The number of confirmed fatal cases reported by World Health Organization is 6,261,708 as of 13th May 2022. Studies have been carried out on promising developments in the field of computer science and on the early detection and prevention of the spread of this pandemic and possible future pandemics. With the accuracy rate in machine learning techniques, reaching satisfactory levels, health studies using IoT and machine learning started to increase. Now, let's look at the main motivation for our work. The number of IoT devices, which is approximately 22 billion today, is expected to be around 15 billion by 2030. As the number of IoT devices increases day by day, the amount of data that needs to be produced by IoT devices is becoming very large. IoT devices are known to have processing capacity and energy limitations and need external processing power and resources to process the huge amounts of data they generate. One of the methods used to meet this need is cloud computing. When cloud computing was first introduced, users were charged according to the resources they allocated, not the resources they consumed, leading to extra cost. To reduce these costs, it is necessary to rely on dynamic scaling of the resources. To solve this scalability problem, the concept of serverless computing was introduced recently. Serverless computing is a model that scales automatically depending on the customer's resource needs and works with a pay-as-you-go policy as a pricing policy. The customer doesn't need to allocate resources in advance, and the system is scaled as needed. In this way, the processing power and resources required for processing the large amount of data produced in IoT applications can be provided thanks to serverless computing. In healthcare applications using IoT, it is difficult to ensure data integrity due to nature of IoT. The data of the user stored in the database shouldn't be changed, so misdiagnosis and negative problems that may arise as a result should be prevented. Here, blockchain is one of the most useful technology to offer information security. Literature reported that there is no existing solution which can handle dynamic scalability and data integrity simultaneously for IoT-based COVID-19 detection. In this work, we propose novel IoT-based COVID-19 detection framework called AIBLOCK, which uses serverless computing and blockchain. Okay, in this work, we propose novel IoT-based COVID-19 detection framework called AIBLOCK, which uses serverless computing and blockchain. Literature reported that there is no existing solution which can handle dynamic scalability and data integrity simultaneously for IoT-based COVID-19 detection. The main contribution of this work are we propose a lightweight framework called AIBLOCK, which leverages serverless computing to offer scalability for IoT-based systems. AIBLOCK guarantees the immutability of the data collected from users and uses blockchain to ensure data integrity. Machine learning models are evaluated using accuracy, recall, precision, and area under curve parameters, and disease detection is performed with high performance by using the model with the highest accuracy in AIBLOCK. Google Cloud Platform is used to evaluate the performance of AIBLOCK in serverless computing and demonstrate that AIBLOCK gives better performance in terms of quality of service parameters such as throughput and average response rate. Experimental results show that AIBLOCK offers dynamic scalability by responding to increasing the number of user requests. AIBLOCK framework basically consists of three main layers. These IoT layer, gateway nodes, and serverless data center layer. The IoT layer forms the first layer of the framework. IoT devices can be used to receive and transmit data from sensors via communication protocols such as ZigBee, Bluetooth, Wi-Fi, and Bluetooth Low Energy. In our study, we assume that the user data is taken from the sensors using the Raspberry Pi 4, an IoT device. This data is sent to the server over the secure communication channel using the TLS protocol. Gateway node is the midpoint between the IoT layer and the serverless platform. The data received by the sensor of the IoT layer are sent to the gateway nodes. Then the gateway node sends the data to serverless data center. Serverless data center layer can be regarded as the most important part of the framework, as in this part every computational work is carried out. Data from the IoT is processed in this layer by a previously deployed machine learning model to find the COVID-19 detection result. In addition, blockchain transactions for data integration are also performed here. Blockchain is responsible for data integrity. It is present as a serverless platform which creates a block with input data and the predicted AI outputs. The final hash formed with the data and previous block is sent to gateway for validation. In our study, Google Cloud Platform Cloud Functions with serverless computing architecture was used. First of all, health data from users is received via sensors and sent to IoT device in the IoT layer. It is assumed that Raspberry Pi 4 is used in our study. Health data collected at the IoT layer is sent to gateway node and then forwarded to the serverless node. In the serverless node, two different jobs are performed. One is to determine whether users have COVID-19 through the machine learning model that has been deployed before. The other is to process the result indicating the COVID-19 status, together with health data from the user, into blockchain. The purpose of doing this is to prevent an unwanted external intervention against the COVID-19 detection status and health data by providing data integrity with blockchain. The COVID-19 detection status and the current hash of the generated blockchain are sent to the gateway node, which also acts as a user interface and displays the output to the user. This hash is saved in the server database and allows data verification by comparing it to the hash data of the user gateway. If any attempt at changing the data takes place, the hash values in the blockchain will also change and the data held in the two databases will not match. In this way, data integrity will be guaranteed. There were 20 health-related data and one variable showing the COVID-19 infection status in the dataset. The correlation matrix operation was applied to find the variables with the highest correlation in the dataset. Then, by applying the activate shape models feature selection methods, the top 10 variables that best explain the dataset was determined. The figure shows 10 variables used to train the machine learning model. We evaluate the performance of the proposed system, AIBLOCK, from three different perspectives. Firstly, we found the model with the highest accuracy rate among the 5 different machine learning models. We only needed to find the machine learning model with highest accuracy one since only one machine learning model is used in the system. Secondly, we evaluate server performance by using three different metrics. These are throughput, the average response rate, and cold start latency. Throughput is the average of the successful delivery of messages passing over the communication channel. And the average response rate is the average of the response time given by the server to the request sent by the client. And the cold start is serverless computing scales idle resources to zero, thus working on a pay-as-you-go basis. There is a certain latency in reallocating these resources, which are scaling to zero for functions. This latency is called cold start latency and can be problematic for time-sensitive IoT applications. And finally, in the thirdly, we run the system without blockchain to measure the additional payload that blockchain brings to the system. After data pre-processing, we applied hyperparameter optimization to all the machine learning models we used to find the highest performance rates. These values are shown in Table 1. Next, we identified the machine learning model with the highest performance for the detection of COVID-19 for the 5 different machine learning models used. According to the model with the highest accuracy is the random forest model with 1980.40. 98.40%, and the model with the lowest accuracy is linear regression with 1960%, 96%. Therefore, it is sufficient to deploy the random forest model to server for COVID-19 detection. In this way, COVID-19 patients are detected using random forest, the nearest health institution is notified, and the spread of the disease is tried to be reduced. Within the framework of the AI block, we use a cloud infrastructure that automatically manages resources and includes serverless computing with scalability. In this way, we examine the parameters that take into account customer satisfaction, such as quality of service, in response to the increasing number of users. Therefore, by testing our proposed work in a serverless and non-serverless platform, we compare the performance of the two platforms and show the superiority of serverless. In Figure 6, we deployed our machine learning model to Google Cloud Platform Cloud Functions as a serverless platform and deploy it to Heroku as a non-serverless platform. We created post requests using gmeter in order to send the number of concurrent requests to the platforms. And we gradually increased number of concurrent requests, and it is for modeling the number of concurrent users. Therefore, Figure 6 shows how much throughput the two platforms are able to respond to these users as the number of users using the system increases. As can be seen from the figure, the serverless platform has much higher throughput. To make another performance comparison, we measured the server's average response rate versus number concurrent of requests. Our aim in doing this is to measure the performance of two different platforms for latency-sensitive IoT applications such as autonomous vehicles, simultaneous patient monitoring. Figure 7 shows the average response rate of the platforms versus gradually increasing number concurrent of requests. As can be seen from the figure, the serverless platform can respond to requests sent by the client much faster thanks to its dynamic scalability feature. Another thing to note is that 100 number concurrent of requests has a higher response rate than 200 on the serverless platform. The reason for this is the cold start problem seen in serverless platforms due to its zero scaling feature. Cold start latency has been measured to be approximately 5 milliseconds. Within the framework of AIBLOCK, we use blockchain in the cloud to ensure data integrity and machine learning model for COVID-19 detection. We measure the additional load that these two methods bring to system. To measure these, machine learning and blockchain modules were deployed locally on a personal computer. The memory consumed by the system in a RAM was measured when only the blockchain module was running, only the machine learning module was running, and both modules were running. Table shows the experimental results of memory usage. As it can be understood from the results, when designing system using blockchain, the amount of memory that will be needed beforehand should be taken into account. IoT devices are inherently resource limited and data integrity is difficult to ensure. In this paper, we proposed a blockchain-based framework called AIBLOCK to offer the data integrity required for applications such as Industry 4, healthcare, and online banking. In addition, the proposed framework is integrated with Google Cloud Platform Cloud Functions, a serverless computing platform that automatically manages resources by offering dynamic scalability. We test AIBLOCK by applying a study that detects COVID-19 using machine learning. According to the data received from the patients through the sensors are collected in the IoT and sent to the cloud via a secure communication channel. The machine learning model previously deployed in the cloud processes health data and returns a result indicating the COVID-19 status. These results and the health data from the IoT are processed together in the blockchain module, and a copy of the resulting hash is sent to the IoT and cloud database. In case of an intervention on health data or COVID-19 results, hashes will be changed and external interventions on health data will be determined by ensuring data integrity. The performance of five different machine learning models is evaluated and compared in terms of accuracy, precision, recall, F-score, and area under the curve. The experimental results show that decision tree gives the best result in terms of accuracy. Further, it has been identified that utilization of blockchain technology can increase the load on memory. And as a feature work, in the future work, a mobile application can be designed for AIBLOCK to collect information from the patient automatically from the wearable sensors. AIBLOCK can be used for other disease diagnoses such as diabetes, heart diseases, or cancer. Further, AIBLOCK can be used for other IoT applications such as agriculture, traffic management, weather forecasting, or smart city. Also, by applying constant latency reducing techniques inherent in the serverless computing paradigm, this framework will give much better performance for time-sensitive IoT applications. Okay, thank you very much for listening to me.